We're clear.
Looks more clear.
Yep. That's bad. That's better. So cool. All right. I guess I'll wait for everyone to get back in here. Do. Hi. Uh, I hate when things mess up. Oh, Danny. All right. So give people a few to get in here again. Share Facebook. Share. Go on my page. Share. Group. Post. All right. There we go. Whoops. Delete the other one there. There. That's been cleaned up. All right. So, all right, everyone. So we've talked about low voltage wiring. We've talked about relays and controls. So now we're going to talk about thermostats and go from there. So let's talk about some do's and don'ts with thermostats. All right. So the first thing is when you get a thermostat out the box, make sure it's for the equipment you're going to be using. Okay. So make sure it's for proper equipment. All right. And when I say proper equipment, I mean, if you're using a thermostat, just say for a boiler, which only has a R and a W, and your thermostat does not have battery power on it, then you're going to have a hard time making a 3-wire connection with just 2 wires. You need that common. So make sure you're using the right thermostat for the right piece of equipment. Um, Now, a lot of thermostats can do a lot of things, but not all of them can do that. So, I'm going to back this up just a hair so you can kind of see me as I'm off the side a little bit. Um, Second thing is proper location. So you want to make sure you're installing the thermostat in a spot that is going to be centrally located of the house, close to return, not in the back room of a dining room away from any traffic of the house whatsoever. If just to give you an idea, I'll draw a little house here. Let's see, family room, dining room, living room, kitchen. There's a bit of bath here. If you put your thermostat over here in a back room that has no real way of sensing the return, that is all the way over there in the hallway, it is not going to get good air circulation from over here. Over here it will, but over here it won't. So you got to make sure you put your thermostat over here in a good central area by the return and not in a back room. When you put them back here, it doesn't give you the proper airflow. It doesn't give you that proper sensing of the house properly. So just keep that in mind when you're looking at thermostat replacement stuff. Um, I know my neighbor across the street, he had a thermostat in that exact same situation. It was in the back room of his dining room. And you're not getting the proper circulation of air when there's the returns in the hallway. So his air handlers are on the stairs. So I took his thermostat and relocated it to right there in that hallway. And his house is definitely more comfortable than what it ever was before. So a don't is in a off room from return. Okay. That's something you don't want to do. Um, Also, let's put down wrong equipment. And you're thinking, how can I go on for this long about thermostats? Trust me, there's a lot of information about thermostats that people don't realize that they do wrong. All right. So, next thing, if you are in a regular house, if you look in paperwork, 5 feet from floor. All right. Basically, that's eye level for most of everybody out there in the world. You want it, the thermostat manufacturers want them at 5 feet. It used to be in the paperwork, but that's where it is. Um, Also, American with Disabilities Act, ADA, 15 inches to 48 inches. Okay. That is the requirements by ADA. All right. Now, 15 is a little low from the floor. 48 is up here. I usually go about the 42 mark. Because if you look at it, sit at it, you take a tape measure, you measure, you're about the 40, 42 mark when you're looking at something. So that's generally where I like to put it. Because if I think of myself in a wheelchair, I want to be able to see the thermostat, not to look up or look down. I want to be able to look right at it. Just like as we walk up to the thermostats, we can walk up to it and our eyes are right there at that thermostat level. That's why these numbers are important on this. Um, yes, ADA like nursing homes. Exactly, Kanan. So that is important to know. Um, there are also other ADA requirements we were talking earlier about bathrooms and stuff, but this you can go ADA 15 inches from the floor to 48. I personally go 42. If you want to try and sit down and take a tape measure and hold it up from the floor and see where your eyes focus on a straight a level across, and it's going to be about the 42 mark. All right. Let's jump over here to the don'ts. Let's say too high. I have seen thermostats mounted at 6 foot and higher. And people are like, I can't read that. Well, you can't. Now, commercially wise, they have to be at this as well in commercial settings. Okay. Because a commercial space that is accessible by the public has to have thermostats at the same requirements as ADA for that reasoning. Now, you can, in a space, you can put any stat, any level with a lockbox. Once you put a lockbox on there, you negate any requirements by code. Lock boxes are oversight and they supersede code requirements on anything. I could put the thermostat at 5 foot, I could put it at 6 foot as long as there's a lockbox on it. Um, yeah. Um, Yes, ADA's residential houses too. Now, I know there's a church over in the county next to me. They have the thermostat at 7 feet with a lockbox on it. Because the lockbox is there, it negates any requirements of manufacturer requirements or code requirements of where it can be. So any level with the lockbox, put the L there. So that's a thing to know. All right, you don't want to put a thermostat in room with a heat source. Okay. Now, when I say a room with a heat source, it could be a family room with a fireplace, a kitchen, um, something that's going to provide a lot of heat. It can throw the thermostat off and create the system not working properly. Another type of heat source is direct sunlight. Okay. Sun hitting the thermostat is going to throw the house off as well. Um, Another good one that you can have is behind a door. If you got it behind a door in a corner or something, it's not really going to be in a good location for accessibility. Uh, Dues. There's still a lot out there. I was hoping more people would be here so we can ask questions, but we haven't shown up. So I'm gonna continue going like this. Central location, well, proper location in central. Inside wall. Now, with the inside wall for good, what do you think's an outside bad one for the outside wall? The bad one for the don'ts. An outside wall. Even though your walls are insulated, they do not allow thermostats to be on the outside wall because they can still sense the cold temperature from the outside. If you have a concrete block house with the fur strips on them with no insulation, you put on the outside wall, that thermostat's going to be running cold all the time. Yes, the humidity from the fish tank and everything with that fish tank definitely don't want to be anywhere near there. We've noticed that we have some stores that do have fish and chemicals, and they're like pool stores, and they affect the thermostats and system operations all the time, especially come summertime. It is just trying to remove all that humidity from the water in the fish tank business, or the water from the pool place, where because they have little operational spas and jacuzzis in there, and they're just trying to pull that humidity out. Plus, the chlorine chemicals in the air eat up a coil. It eats up a unit. It just disintegrates it. It kills it. So yes, you just don't really want to have stuff like that where all that can happen. What I would recommend on that there, even though it's all in the air, to try to mitigate some of that, is put remote sensors in and put the thermostats in a room away, like an office, something away from all that chemical air as much as possible. But you're still going to get it, but it might help prolong something like that. Um, Remote sensors. We have a lot of those these days. When you're putting them in, make sure you put them in the proper locations as well, because they can also act like the thermostat. So you want to make sure they're the proper locations. lamps, and TVs. I have had thermostats underneath lamps causing problems. So you don't want them there. And that needs to be over here. Excuse me. Put that on the wrong side. Well, when I say that, Canon, it's more or less basically you don't want the sensor down low to the ground or up high on the wall. If you've got a remote sensor you're going to be putting on a wall and putting the thermostat hidden somewhere else, like in an office, you want the remote sensor still at that 5 foot, basically, or the 48 that's requirement. You still want to use that remote, mount that remote sensor as if it was the actual thermostat. So you want to make sure you're keeping that still the same. So you're not causing any kind of issues with that. That's the tech support line. That's all Jennifer. Let's see here. So far we got a good do's and don'ts list going so far. Let's close to return. That way you're getting a good air mixture. You don't want to buy a supply vent. A buy a supply vent will cause the thermostat to short cycle and not either heat or cool the house properly. I've had people say, my house is cold. And everything right here is so warm. Well, you got a vent right here blowing warm air across your thermostat that's causing that problem. That vent's either in the wrong spot or your thermostat's in the wrong spot. And you got to return 2 feet away. So that vent and that return, all you're doing is sucking that air in, but it's also blasting warm air across that thermostat. Yes, by returning during new construction, that's where they all should be. Because if you put them by the return, that means you're going to get a good, when the air's going to come across there, it's going to get a good mixture. Um, so it basically senses pulls all the air from all throughout the house across that thermostat. Essentially, that's the purpose of it. And sorry for the alls, the ums, and the stuff. My brain's 100 miles an hour right now. So this is basically main information for thermostats. Locations, do's and don'ts. Any questions so far? Well, maintenance room. The thermostat on the wall in the house, but the maintenance in the maintenance room. So the thermostat was in the same room as all that equipment, Canon? There's one more don't. Yeah, I'd try to get a supply in there to kind of compensate that area. There's one more don't that's a controversial don't. I'm gonna put it over here with a question mark. Now, reason I say bedroom is you do and you don't do that at the same time. So if you have a zone system, you're zoning out, you make the master bedroom a zone and the other kids a separate zone, then yeah, you want one in the bedroom and one in the hallway. If you have a house that has an open floor plan where you go upstairs and you have openness from the first floor to the second floor, all that natural heat is going to rise and hit that second floor. So essentially, you kind of need to have a thermostat at that point there away from that open floor plan and put into a room to prevent it from overheating. Because if it overheats in the wintertime, that second floor is going to get too hot or going to get too cold. It's not going to move air properly because the thermostat is sitting right there in that open area and all that hot air is just keeping it from running and the other rooms are going to get cold. So if you put it in a bedroom, then that room is not getting hit by that hot air and actually can make the system come on and operate. Okay. Same thing with the summertime. That all that heat's going to go upstairs. If it's sitting in that open floor plan area, that second floor is going to run nonstop trying to cool that room down because all that heat is just all that cold air is dropping and it's just pushing all that hot air right back up. So you got to kind of have to look at the floor plan of the house for bedroom. How is it looking and where do you want to go with it? Always check for cross overseas. Doesn't make any sense to me. That might be a Bama thing. All right. We'll wipe this clean and we're going to go on with the next section. A little spray. Crossovers, you means like vents from one room to the other? I really need a better stand. This thing is so flimsy. All right. Yeah, so we call those we don't call them crossovers. We call them transfer grills. So with the energy code, you don't put returns in all the rooms. You put transfer grills to go from across above the doors, so it allows air to transfer between the rooms and the hallways. All right. So with our thermostats, we're going to go with this route here. I have a heat pump in the house. Okay. I have a. Let's not do heat pump. Let's do this. Let's do a more common thing because not everyone's gonna have a heat pump in there. We have an AC system, and let's go with a boiler. Okay. So with our AC, we're gonna have R, Y, G in common, right? A boiler, R and W. So if you have a house that has a boiler with radiators and your house also has AC as a separate system, and you have one thermostat over here and one thermostat over here, you could take both of these intertwine them into one thermostat. Because on all thermostats, you have the RC and RH terminals. RC will control the Y and the G. The RH will control the W. The common is a set point to both of them. It powers the thermostat off of this, and it makes the RH a dry set of contacts. So if you notice on your thermostats, it'll say RC, RH, and you'll have a jumper wire in between them. Okay. On the T6, the Honeywell T6s, it's down here on the right hand side, and it says one wire, two wire. There's a little switch you move right here. So that way you can say, I want one wire, so it's going to do RCRH. If you do two wire, it basically disappears this jumper internally and allows you to control the heating off of one thermostat and the cooling off of the cooling system off the other side of it. So you can do that. Now, if let's say I got a customer who they have a heat pump with a gas boiler. Okay. With that, same thing. We don't do this essentially. We do something a little different. And I'm going to draw it out for you. But just to give you an idea, let's just sink this in for a second. And then I'll show you how that's done. It's done a little differently, but the same concept. So we have heat pump, boiler, R and W, right? Heat pump, R, W, Y, G, O, C. So we put this on our thermostat here. Okay. Here's our thermostat. We wire all this to our thermostat just like normal. Our boiler, we want our boiler to come on when it gets below 35 degrees. Okay. So we put a temperature sensor on the system. We take the W wire, common, open. So W will come to our common. That's going to be our 24 volts constantly going to this. All right. Normally open will go to our boiler. Normally closed will go to our outdoor unit. So when this gets 35 or below, it'll switch the W circuit when it calls for heat on this from the thermostat to here. Okay. Now we also have not W circuit, my bad, Y. It takes the Y circuit and switches it over. The outdoor unit W from here goes to the air handler. That's the thermostat. There's the air handler. Our emergency heat still goes not to here. W is a direct line straight to the boiler relay. So this is because we have a 9340 fan relay wired into the system. It's a little complicated for beginners, but and we have a temperature probe. outside. The old school dual fuel control, basically. That's all it is. It's got a sensing bulb on it that sits outside the house. So you can do two systems off of one thermostat still. It's a little confusing. It's a little crazy. I'd have to draw out the schematics a whole different way, but just for class purposes, just letting people know you can do multiple systems like this off of one thermostat. Just depends on what kind of controls and relays you have to allow this to happen. All right. So just a little fun factoid. This is a customer's house. This can be done. And we get more into controls and stuff. I'm gonna get more relays and parts and stuff in here um, to show these things and how they operate and everything else. Not everyone gets to see a lot of these controls out there. So the next part of what we're going to talk about, turn it towards me here, zone boards. Okay. Now I have this one right here. It's a Honeywell zone board. All right. So right here, DATS, that is your supply air temperature sensor. Okay. Over here, where it says ABCD, that is for your wireless controller setup. Right here, it says RNC. So when you buy a zone kit, it comes with a separate transformer to power this. All right. Now, if you're old school like me, where it says equipment here, you have an R and RH, but no common. So RH, RC, there is no common on this equipment side. So what a lot of us old school guys do, we just take an extra jumper wire from R, bring it down here to this R, and bring the common here. Can the transformer handle it? 99% of the time it can. But you can also just apply the other transformer to keep it going. Then you have, excuse me, on this side here, we have zone 1, zone 2, and zone 3 over here. This board problem was zone 2 is acting up and not sending signal to the equipment to make it operate. So one thing you could do is you could go back into this configuration, reprogram this board, and make it a 3 zone and wire everything over to the 3rd zone and be operational. Another thing you have to be careful of, these little push pins, right? If you push too hard on these with a screwdriver or something, they will snap and break off. As you can see, there's a spot for only 2 wires to go in here. So if you have more than 2 wires, you are not going to have fun. It's not going to fit them. They barely fit the wires that's in there now. So you're not going to have fun trying to fit more than 2 wires in these terminals. If you notice on this board, it has an R, C, W1/E, W2, Y1, Y2, G, O/B, and L. Well, this is the 3 zone board. The 4 zone board looks like this. Now the 2 zone board looks like this, but doesn't have this control here. Okay. With that being said, guys and gals, when you have a zone board, make sure you read the instructions on them. It's always good to have them and to read them. All right. On this here, this one says if equipment for thermostats with separate OB terminals, attach O for cool changeover or B for heat changeover. So you wire your thermostat up just like normal with a with a 3 or 4 zone control. In the zone control setup configuration, it'll ask you reversing valve heat or cool. So it tells you you tell it what's going to happen. Now, if you're using a 2 zone control panel, you want to wired up for reversing valve cool. Okay. Program your thermostat for reversing valve cool. Okay. Because when the thermostat is in the heat mode, the board won't sense that 24-volt control, and it'll automatically energize the reversing valve for you in the heat mode. I know this for a fact because I had installed one and I was freaking trying to figure out why I was not working properly. It just was killing my head. We wired everything up. We put reversing valve heat energizing on the thermostat, and the unit kept going into the cooling mode. And we're trying to figure out what's going on. Why? Where are we messing up? The instructions were not very clear. And when I called tech support and told them what's going on, they laughed. They said, "Yeah, we know our instructions are not very clear on that because of this. We have this conversation a lot with people with the new systems coming out." And he said, "Switch your thermostat to reversing valve cool. Everything will be fine. It'll sense that it'll sense the 24 volts for cooling, and it won't energize the reversing valve for heating. When you put it into the heating mode, it's sensing that 24 volts. So it's thinking, okay, I need to bring on the reversing valve. So you have to trick the system in saying what kind of system you actually have. So next week, when we start with the board that's over there, I'm going to power this up. I'm going to get a transformer, plug it up, and plug it up into here so you can see the programming of this, of the controls and everything else. Um, and see how it works. I'll by then, hopefully by next week, I'll have a couple thermostats. I'll have some lights in here on the zone damper controls to show you the dampers being opened and closed, along with the light indicator lights here. Zone boards, understanding them of how they operate and how they work are great. You can do a lot with them. Now, if a zone board fails in someone's house, you got two thermostats or three thermostats. The nice thing about the dampers is they fail spring open. Pull your equipment side off of the zone board, pick a thermostat, wire nut them together, pull the common off the bolt, make sure you pull a common from the unit over. So if you do the old school way cheating of using the common from the unit to power the board versus a separate thermostat, great. Do that. You can wire that into the common, and then you can have the system operational until you can get a new zone board, especially if it happens over the weekend, because we all know supply houses charge a lot of money to open up for you if they're closed. Should be sponsored by them. I drink them a lot. Shameless plug. So I know there's not a lot of people here. I was hoping to have this a little bit more interactive. But if anyone has any questions on anything, please feel free to hit me up on Facebook, message me on Facebook through the Chicks, tag me in a question. I'll answer it. I'm on tech support Fridays and Sundays. Trying to call me then, unless you need tech support, but hit me up, message me. I'm here to help out. Like to make this more interactive, but not a lot of people showed up today, unfortunately. It's a busy weekend, Valentine's weekend. Everyone's away with their lovers. So next week, we've messing with the board, messing with the zone board, playing with controls and relays, talking about how systems set up and operational, and going from there. Other than that, y'all, this was a little short and sweet to the point. I'm gonna give it about 5 more minutes before I end this thing in case anyone jumps in and has any questions. I don't know who's in here now. Just show I have one person. And you're now a moderator for me too now, Danny. We do it for the cause, for the chicks. HVAC chicks, that is. Oh, excuse me, HVA chicks. Jennifer. All right, y'all. Have any questions? Feel free to message me. Hit me up on Facebook. Hit me up on Messenger. You have questions, tag me in them. I will get to them and we'll go from there. Everyone have a good one.